Here we can see the pilot scale demonstrator that we have developed to conceptually validate the technology of recovering heat from the waste gases and generating compressed air. In order to simulate this, we are generating a combustion gas that now we have it at 1088 degrees C. This is the temperature at which the gas is exiting from the post-combustor and going to the quenching tower. There, the gases are cooled down to 372 degrees C, as we can see here. These gases are exiting at this temperature from the quenching tower and going through this duct to the heat exchanger. This is the cell and tube heat exchanger in which the waste gases transfer the heat to the water. Then, once cooled down, the gases are exiting at around 120 degrees C and going to the back filter where they are filtered and they are going to the atmosphere. Once the hot water is heated, it goes to the ORC system where it delivers the heat to the organic fluid in order to activate the transmission system that we can see it here. This is the transmission system that is generating a mechanical energy, and the shaft is rotating at around 6,000 RPM. Then, with this velocity, we are generating compressor. We are activating the compressor in order to generate the compressor, as we will see now. Here we can see how we have compressed air at 6.34 bars. This is maintained constant because the compressor we are generating is the same amount of compressor we are generating. It is leaving from the tank. Here we can see the flow meter, how the compressor is entering at around 180 liters per minute, and this compressed air fills the air tank up to 6.5 bars at the moment, because as I have seen, some air is leaving from this valve. The same amount of air we are generating is leaving from this valve, so the pressure is maintained constant. This is the control system of the transmission system. We can see two different graphs. In the upper graph, we can see three different lines. One is the set point of the red one is the set point of the pressure. The green one is the pressure at which the air is entering into the tank, as we can see around 6.5 bars, and the blue line corresponds to the flow rate of the air at around 180 liters per minute. In the lower graph, we can see two different lines. The red line corresponds to the mechanical power we are having in the shaft of the compressor, and the white line corresponds to the RPMs of the shaft that are around 5,000 and 6,000 RPM, as it can be seen also in this point of the graph. And here we have the ORC unit. The ORC unit is activated with pressurized hot water. The hot water is exiting from the heat exchanger at around 105 degrees C, is entering into the evaporator where the heat is transferred to an organic fluid, and then the water exits the evaporator at around 90 degrees C and goes to the air temperature. You can see that we have the set point at 99 degrees C. So this is the temperature in which the hot water is exiting the air temperature and goes through this pipe to the heat exchanger again. Going now to the evaporator, we are transferring the heat to the organic fluid. This organic fluid is evaporated here and goes to the expander, and the expander activates the mechanical rotation. Then the organic fluid goes through this pipe to the condenser, where it is again cooled down using cold water. This cold water is heated from room temperature to around 35 degrees C. Then, once it is cooled down, the organic fluid goes through this pipe to the pump, where it is pumped with a compression ratio of 4 and goes again to the evaporator. Now we are going to show the control panel of this ORC system, where we can see the different parameters of temperature and pressure. We have 3 different elements. The orange one is the heat exchanger. Gases are entering at 350 degrees C and going out of the heat exchanger at 125, and they are heating the water from 86 degrees C to 104 degrees C. This hot water goes to the evaporator with a flow rate of 1,500 liters per hour, and here they deliver the heat to the organic fluid. This organic fluid, as I have told, is evaporated and with a 90 degrees C temperature activates the expander. Then they are cooled down to 45 degrees C and go to the condenser, where they heat the cold water from room temperature to around 38 degrees C. This one is the flow rate of cold water, and this is the pressure of the organic fluid. From this control panel, we can control the whole system. We can start up the ORC unit, and we can stop it also.